Hello, Year 8, and welcome to what is going to be a new topic of fractions this week. Just going to take a moment to explain the rationale behind what we are doing. So obviously I am now setting work for set 1 and set 2 with the topics for the foreseeable future. The idea behind this is it is a very time-consuming task, producing videos and resources that we are putting online, and in order to make the lessons as consistent as possible, but also to give staff time to provide high quality resources, we have just restructured how we are organising ourselves. So regardless of whether I'm your normal teacher or whether your normal teacher is Miss Hankovich or Mr. White or a combination of the two, you're stuck with me for the next, well, we'll see how long it goes. That your normal teachers will still respond to you in the Ask the Teacher channel. They will still be monitoring that you are completing the work. So, I've said we're going to be doing some work on fractions. Now, the topic of fractions is something you will have met at primary school. I am very aware of that. However, the topic of fractions was also a topic that in Year 7 we met during lockdown. So how much work you will have done on fractions and how much success you will have had at fractions from Year 7 might be a little bit varied. So we are going to take this steady because it is a topic where we need the key skills in order to progress onto more challenging aspects. But I'm hoping by the end of the course, by the end of this topic, we will be looking at more complicated work with fractions and maybe even bringing in the topic of algebra as well. So please look forward to it. So to wake up those brains, we're going to start with a little activity where in a moment you're going to pause the video and just have a little bit of a think. It says, look at each set of 3. Which do you think is the odd one out and why? There might be more than one answer and reason. So I'm looking for a really good mathematical reason to why one of these is the odd one out, not just some superficial reason like, oh, 2 of them are fractions, one's a decimal, the decimal's the odd one out. So have a little bit of a think, pause the video here, which one is the odd one out and why? So the odd one out in the first section I was looking for was actually 2/3. The reason that 2/3 is the odd one out, in my opinion, is because 3/4 is equivalent to 0.75. You might recall there are some equivalent fractions and decimals, and this is something we'll be doing some work on later this week. In the second box at the top right, which one is the odd one out here? Well, personally, I was looking for the answer 6/12 being the odd one out. Reason being, 9/15, if you cancel it down, is equivalent to 3/5, so these two fractions are actually the same. The bottom left, the third one, is very similar if you do a little bit of cancelling of fractions. These can be divided by 7, so this is 4/7. These can be divided by 5, so this is equivalent to 3/7. And these can be divided by 2, so this is also equivalent to 3/7. So I have 28 out of 49 being the incorrect answer. Final one, again, you might have gone for a superficial reason. This is a mixed fraction. These are improper fractions. But what I was looking for is 7/3 as being the odd one out. Because at the end of the day, if you have 2 whole ones, that is 6/3. So 2 and 2/3 is actually the same as 8/3. How did you do? So for our first lesson on fractions, we are going to be looking at comparing fractions and using some inequalities. If you've forgotten what inequalities are, don't worry, we'll be talking about those in a moment. You'll also notice in the instructions there is a sheet that you can print out. Now, if you do have access to a printer, that is great because that will speed up the process for me delivering the lessons. So I'm always going to try and reduce how much writing you need to do by providing you sheets where possible. But I'm also aware that not everyone will have access to a printer, and I'm afraid if that's the case, I will be expecting you to set out the work in your book using titles and objectives and copying the work from the PowerPoints. Now, at any point during one of these videos, if I'm not giving you enough time to write things down, just pause it and work at your own speed. Never, ever, ever work for more than an hour. I cannot anticipate how long something will take for you. So after we finish the main teaching part of the lesson, check how much time you've got left and complete as many questions as possible. Okay? There is never an expectation that you will do absolutely everything. So I've said a fraction is part of a whole one. And if we are comparing fractions today, well, some fractions are incredibly simple and obvious. I always like to use pizza. Why? Because I like pizza. But, I mean, immediately, if we look at these fractions, 2/3, 1/2, it's immediately obvious which of those is bigger. However, just saying, I know it's bigger, isn't really enough to mathematically explain a statement. So what we need to decide is how we can do this. How can we say one fraction is bigger or smaller than another without using pictures? Now, there's two approaches that we are going to use to do this. The first one is where we take our fractions and rewrite them as another fraction, an equivalent fraction with common denominators. So let's see how this works, and then we'll talk about our inequalities. So you can see in my first example, 11/27 and 4/9, these fractions do not have the same denominator, the same bottom number, but there are equivalent fractions that we could use where we could make the bottom number the same. You'll probably have noticed that 27 is a multiple of 9. So if I take the numerator and the denominator of this fraction and times them both by 3, I will have a fraction out of 27. 4/9 is equivalent to 12 out of 27. Now we can explain which of these fractions is larger. If the denominator is the same, then the fraction with the larger numerator is going to be the bigger fraction, or the fraction with the smaller numerator is going to be the smallest fraction. So I've now identified that 4/9 is the larger fraction out of 11 and 27. Now, I know some of you will be still hell-bent on a crocodile eating the bigger number. And, well, it works, but you really need to progress beyond this and know what these are called. So if I know that this is the bigger fraction, I know that 11/27 is less than 4/9. So, just as a little note up here, this inequality is less than, and this inequality is greater than. And one of the reasons why it's really important to actually learn their names is as we progress through school, we won't always be using these inequalities with just numbers either side. So you won't be able to do that idea of the crocodile eating the bigger number. So we need to learn their names. One way that I remember it is kind of the way that the arrow points in an inequality. If I imagine I had a number line, well, that arrow would be pointing towards the smaller numbers. So I associate that with smaller, less than. Similarly, an arrow pointing this way is pointing to where the larger numbers are, and that's nice and easy to then remember as greater than. Let's look at our second example. Now, you'll probably have immediately noticed that neither of these numbers are multiples of each other. So in this example, I'm going to have to alter both fractions and find my common denominator. And I can find my common denominator by finding the lowest common multiple of 5 and 8. In this case, it is the number 40. I'm timesing this one by 5, the numerator and the denominator, to find it out of 40, and I'm timesing this one by 8. And you've probably also noticed, oh yeah, 5 times 8 is 40. So there's my common denominator. So if I'm multiplying the numerator and denominator by 5, this one is 15. And this one is 16. So again, 16 is the larger fraction. 15 over 40 is less than 16 over 40. Final example for method 1. What's my common denominator for 9 and 12? Well, I could multiply 9 and 12, 108, but that's an incredibly large common denominator, and there's something smaller. Have you spotted it? 36 works for both. Timesing this one by 4 and this one by 3. So we have 20 over 36 and we have 21 over 36. And once again, we are using the less than symbol. So there is a second method of comparing fractions. And this is going to link in again to something that we do some more work on towards the end of the week. But I'm very aware that some of you might know some of these fractions as decimals. If you could turn both fractions into decimals, it is usually the quicker way of comparing. But there might be some fractions that you do not know as decimals. Let's look at this first example. Well, 3/4, I would hope you would know, is 0.75. 7/10 is equivalent to 7 divided by 10. And I would hope you would know that is 0.7. While 0.75 is greater than 0.70. So I can say that 3/4 is greater than 7/10. But without that bit of working out, just the answer greater than isn't good enough. There must be some sort of explanation. Now, perhaps people in set 1 might know what 3/8 is as a decimal. Perhaps set 2 don't. 1/8 is 0.125, so 3/8 is 0.375. Don't worry, in a moment I will show you how you can do this on a calculator. 2/5, I would hope some of you would know, is 0.4. It is equivalent to 4/10. So which one of those is bigger? Well, it's the 0.4. 0.4 is bigger than 0.3 and a bit. Okay, so 0.4 is greater, so I can say that 3/8 is less than 2/5. So how about this last one, 2/9 and 6/25? Well, I fortunately know both of these as decimals, but some of you might be sat there thinking, I don't know these ones as decimals, sir. I might be able to work it out, but I don't know them. Well, this is where you could use a calculator, because at the end of the day, as a fraction, that line just means divide. And if I do 2 divided by 9 on my calculator, I get this wonderful number, 0.2222222, or as some of you might know, 0.2 recurring, which I can write like that. If you type 6 divided by 25 into your calculator, you should get the answer 0.24. So that's a nice decimal, that's a terminating decimal because it stops. And if we compare these, well, that is 0.22 and a bit. This is 0.24, so this has got more hundredths. This is bigger. So I can say that 2/9 is less than 6/25. Let's look at one final worded question and decide how to do it. It says Joey and Ben have a competition to see who is the better darts player. In 30 throws, Joey hit a 20 11 times. In 22 throws, Ben hit a 20 9 times. Who is better? Well, Joey hit the 20 11 times out of 30. Ben hit the 20 9 times out of 22. Now, I assume the better player is the person that can hit the 20 more times. Maybe they were trying for a 20. But there's not an immediate way of seeing which one of these proportions is bigger. So this is where we could use our calculator and turn them both into decimals. So 11 over 30 comes out as 0.366666 going on forever. So that is 0.36 recurring. 9 divided by 22 is another interesting recurring pattern. It's 4090909. And if anyone thinks they know how to write that with recurring notation, you put dots above the numbers that repeat. Now it's obvious which one of those numbers is bigger. It is the 0.409. So Ben is better because he hit the 20 with a greater proportion. So there are lots of questions on the PowerPoint for you to try. And the way that we're going to try and organise this is there is always going to be 3 levels of questions. Now, you are not restricted to just doing the questions that I suggest. So I'm going to suggest that if you are in a set 2, you're going to be looking at level 1 and level 2 questions. If you're in a set 1, you're going to be looking at level 2 and level 3. But that doesn't mean you cannot challenge yourself if you're in set 2. If you want to have a crack at a level 3 question, you have a go at a level 3 question. If you're in set 1 and you think, I'm finding this quite hard, I'm going to start with a couple of level 1 questions, that is perfectly fine. There will probably be not ever time for anyone to do all 3 sets of questions and mark your work. So always look at what time you've got left and use that time appropriately to do as many as you can, but feel free to say, oh, well, I've spent 10 minutes on level 1 and I've only got a few minutes left. I'm just going to try a couple from level 2. So use your best judgment, please, year 8. So go back to my instructions, follow the link to the PowerPoint, make sure you save time to check your answers and make corrections. As always, if there is any problems, you may contact me or your regular teacher through the Ask the Teacher channel.